Okay, so I want to relate parabolas to equations and just basically the ways that you can write the functions that go into it. So the ways that you can write this is basically you can write it as ax squared. This is our standard form. We won't be talking about it this time, but this is one of the forms. Ax squared plus bx plus c equals f of x. So that just means that that's our function, and it's equaling f of x. You can also write f of x as y, but we're just going to stick with f of x for now. So basically, that would be graphed, right? If you don't know what this is, again, Khan Academy has great videos on functions. I would suggest you look at that. So that's standard form. But another way to write parabolas, again, we're doing parabolas, is something called vertex form. So that would be called a times x minus h squared plus k. Okay. So this is actually a lot easier to visualize, and we're going to be talking about why that's a lot easier to visualize. So equals f of x, right? So we're just here's a parabola, and this is what a parabola looks like. If you don't know, parabola is basically anything that looks like that. It can be in any direction, so it can be like that too. It can be like that. It can be like that. Yeah, so it can be like any of those. It's getting kind of messy. So yeah, so basically that form can be used to represent parabolas. So let's talk about why. Well, this parabola is going to be equal to x squared equals f of x. So that just means that the y value is always going to be x squared, right? So it's going to start at 0, 0, right? So like the vertex, that's what it's called, the vertex, is going to be at 0, 0. So that's how the parabola starts. So if you just have a regular x squared, I can write x squared in vertex form, just to give you, relate it to the vertex form. It would be equal to 1 times x minus 0 squared plus k, right? Plus 0, right? Equals f of x, okay? So that just means that you're not subtracting anything from the x, right? Look at the function, it's just x squared. You're not multiplying really anything but 1, and you're not adding any values, right? So you're just going to have x squared. So that's what it is when it's just x squared, okay? But, so why do we have minus h times a and plus k, right? The reason we have that is so that in the case that we wanted to shift the parabola over in any sort of way, we could do that. So for example, let's start with the k, because I think it's the easiest. Let's say x squared minus 5 equals f of x. That's basically saying that you're subtracting 5 from every x squared. So that would shift the parabola down by 5, and that's what this k does. Okay, so now we're just going to do, we're going to shift the function down by 5, so it would decrease from this point, it would go down, so it would go down to negative 5, sorry. Go down to negative 5, so then the function would look like this now. So it would be the same, but it would be moved down 5. So that's what that k does. If it's negative, it will move down. If it's positive, it will move up. So that's why we have that k. So whenever you look at the function and it has a positive k, you'll know that the parabola is moved up, and if it's negative, you'll know that it's moved down. So that's what the k does. Okay. So now let's talk about the h. Well, h basically moves it horizontally. So if we have x minus, say, so if we wanted to move it right, h would be positive. If we wanted to move it left, h would be negative. So if you subtract something to move it right, and you don't subtract, and you add something to x before you square it to move it left. Okay, so let's say we wanted to move it right and we wanted to move it down. So we would have to change the h, right, because we would want to move it right, and we would also have to change the k because we want to move it down. So the k is going to be the same as before. It's going to be -5 because we're moving it down by 5. So we're going to have, and let's just say that the x value is 3. So we're moving it right 3 and down 5. Okay. So what we would have to do is we would have to have x minus 3 squared minus 5. Okay. So h would be 3 and k would be 5. So you can see why having a k value will allow you to shift it left and right horizontally. And having a k value will allow you to move it up and down. So h value for left and right, k value for up and down, right? Okay, so we've explained 2 of these. Yep, so we still haven't explained why we are multiplying by a. So I'm just going to go ahead and make a new page because it's getting messy. So why do we still multiply it by a? Okay, well, let's just say this is our normal parabola, right? That's what it looks like normally. And this is a skinnier parabola. And then this is a fatter parabola. Okay. So basically what a does is it allows us to make it skinnier or make it fatter. Okay, so I'm just going to rewrite the equation. So let's just say, oh yeah, so like the skinnier one would be 2x squared. Like you're multiplying it by 2. So every single y value on the skinnier version will be double the height of the medium version. So that's why we multiply it, so that we can make it skinnier or make it fatter. You can also see that maybe the fatter version would be multiplied by something else. So it wouldn't be multiplied by 2. It would obviously be multiplied by something like, yeah. So I'm just going to write the function right here. So a times x minus h squared plus k. Yeah, so this a allows us to transfer between the skinnier versions and the fatter versions. So if a is like 2, 3, 4, 5, 6, that will make it skinnier and skinnier. But for example, something like 0.5 will make it fatter because it will make it less than what it was before. So everywhere on the fatter version will be half of what the x version was. Okay. So sometimes you can use this formula to actually graph something. So we're going to do an example right now. Let's say we have, let's just say we have x squared plus 5, and we want to, x squared plus 5 plus, let's just keep it at x squared plus 5. This is going to be a pretty easy example. It's going to be x squared plus 5 is our function. So we would convert this to our a times x minus h squared plus k in order to find out what the parabola would look like. Okay, so we have x squared. We're not doing anything to the x, right? So we obviously our h is going to be 0. We're not doing anything to the x under the exponent. And a, we're not multiplying by anything. I don't see a coefficient, so that's going to be 1, right? Because 1 is basically just regular. But we are adding 5, so k would be 5. So that just means that when we're looking at a parabola, it's going to look like it's shifted up by 5. So I'll write it again. 1 times x minus 0 squared plus 5. Okay. Well, that's what it will look like. Okay. So so that means that we just know that, again, it's going to just be increased by 5 with the parabola. So we put it into our form, and now this is just a graph showing. So we can use this, and we know that regularly a parabola would look like this, right? But our parabola is moved up by 5. We know that because there's a 5 in the k slot, so k is equal to 5. So we know it's going to be moved up by 5. Yeah, so it's going to be exactly like that, except it's going to be moved up by 5. The vertex is going to be at 5. I'll go into more detail about what the vertex is, probably in future videos, but that pretty much wraps it up. Thank you.